All right, this is Unit 11, Guided Notes B, and this one is about quadratic regression. What does that mean? That sounds complicated, but it's not that complicated, really. So if you have Guided Notes B, well, you should have them in front of you. And we're going to look at what quadratic regression is and what it means. All right, what quadratic, it's hard to say, regression means it's finding the quadratic equation that fits a set of data points. And this is how you do it in Desmos. You're going to start by choosing table by clicking the plus sign in the upper left. You're going to fill in all the given X and Y values. And this is what you're going to type. This is very important. And notice that there's ones. Now on the Desmos screen, it's going to, when you hit Y1, it's going to be a subscript. You don't have to do anything. It's going to automatically be a subscript when you type the 1. And you want it to be a subscript. I just couldn't get subscripts in the notes. So this is what it looks like. Ax1 squared plus bx1 plus c. That's what it's going to look like on the screen. All right, the first example, we've got these data points. And these data points are going to look like, they're going to look kind of like this. And we're going to try to find the equation that of the parabola that goes through those points. So let's go to Desmos and follow those steps. And let me show you what that's going to look like. All right, so let's go to Desmos. All right. Now on Desmos, we're going to start by clicking the plus sign here and choosing table. All right. We're not going to erase the Y1 because we're not putting in the equation. We're just putting in the data points. So it's easier if you do the X values first and then the Y values. 0, 0.2, whoops, 0, sorry, 0.2. And then the next one is going to be 0.7. And then 1.3. And then 2.1. And finally 3.3. Then the Y values are going to be 2.3 and 2.2, 2.3, 2.2, 2.1, 2.2, 2.8, and 4.7. All right, those points are a little bit crowded together. If you look over here, see this little magnifying glass? If you click the magnifying glass, it'll make the points look better. It'll spread them out a little bit so it looks better. Now, don't type in that crazy looking command. Type it in the table. Push that on the next line down. So on the next line down, we're going to type in that command Y1. Now the squiggle is right below the escape key. If you hit that, it's right below the escape key. You have to hit shift to get it. And it's ax1 squared plus bx1 plus c. All right. There's, if you look, you can tell that the equation is good because it goes right through the points that we typed in. Now, here are the numbers for A, B, and C here. I'm going to only write those to the nearest 10th. So this is what it's going to, I'm going to write it on my paper, and then I'm going to show you what it looks like. 0.4. Well, let's switch back over. So it's going to be Y equals 0.4 x squared. The 0.4 goes in front of the x squared, minus 0.6, that's my b, and that goes in front of the x. The a goes in front of x squared, the b goes in front of x, and finally the c is 2.3. I just rounded those to the nearest 10th. That's the equation in standard form. Notice the equation does not have the subscript. That's only for Desmos. And also, it has an equal sign, not a squiggle. The squiggle is only for Desmos. Now, the question is, predict the y value when x is equal to 4.5. Now, technically, I'm supposed to plug in 4.5 for x, all right? But there's an easier way to do it. Let me show you the easier way to do it. That's what we're supposed to do, but let me show you a much easier way to do that. Now I'm going to share my screen again, go back to Desmos. All right, if you go to Desmos, just go down here and type. Instead of typing in, plugging in, and just type in x equals 4.5. If you type in x equals 4.5, you're going to get a vertical line. I'm going to have to zoom out a little bit. If you get the vertical line, just look where that vertical line crosses the graph. If you click on it, it should light up. When I plug in 4.5, I get about 7.7 for my y value. So when x equals 4.5, y is equal to 7.7. So that's what you should fill in on your paper there. All right. So when x is equal to 4.5, y equals 7.7. Now, the next example is actually an application. It's kind of a physics application. If you take physics, you'll see things like this. But you don't need, you don't need to know anything about physics. But we've got an object that's launched from the top of a 200-foot building. Now, you don't really need to worry about that because that's just set up. You're going to do this problem the same way we did the last one. But the x's are my seconds. This is how high the object is off the ground after that many seconds. And the y values, that's the height in feet. So this x values are the seconds. The y values are the feet. That's the height. So time in seconds, height. All right, we're going to put all these numbers into a table just like we did before. All right, now, let me share again. All right, here's the Desmos screen. Now, watch what happens if I click plus sign table. All right, if you'll notice here, you see the x2, y2. You can do that, but when you type in the command, you're going to have to put 2s instead of 1s. Now, if you want to be consistent, you don't want the directions to change, just make sure you erase the last problem. If you erase the last problem and choose table, it goes back to 1s again. All right, so let's see. We're going to plug in all the x values, 0, 0.5. If your x values follow a pattern like these do, you can just keep hitting enter and it'll autofill them for you. But you could type them in separately if you want. The y values don't follow a pattern, so I need to type those in separately. 200, 216, 224, 224. Now, how is it 224 at both 1 second and 1.5 seconds? Well, it actually went higher than that, and its object's starting to come back down. So it reached its peak height between 1 and 1.5 seconds. And then let's see, 224, then it goes back down to 216, then 200, then 176, and then 144. All right. Now, I can't see the points. Again, if you remember, I said click on that plus sign. If you click on this little plus sign where it says zoom fit, you can see the points now. So it adjusted the graph so that you could see the points. Now, I know on the paper it says T and H, but on Desmos, you still have to use Y and X. The command is the same, Y1. Now, squiggle is just below the escape key. AX1, make sure you put squared, plus BX1 plus C. And see, there it fits. It goes right through the points for me. All right, so we're going to write the equation down. So the equation is going to be Y equals negative 16x squared plus 40x plus 200. Now, really, I should have written on the paper, I should have actually written it with the same variables they gave me. It's actually H equals negative 16t squared plus 40t plus 200. All right. That's really what the equation should look like. The A goes in front of the square, the B's goes in front of the X, and the C goes at the end, but it should have been H's and T's. Now, all of these questions here can be solved by just clicking on the graph. All right. Let's look. All right, so let's see the max. All right, so let me share the screen again. You can fill these in yourself. Now, the max height, if you click at the top of the curve, this little gray dot here, the maximum height is 225 feet. So write that for the maximum height, 225 feet. The 1.25, that's the seconds it takes to get there. So the time it takes to reach the max height is 1.25 seconds. Okay? Now, what is the height after 4.5 seconds? All right, you'll need to type that in. Remember, time is x. So you're going to type in x equals 4.5. And we're going to have to zoom out a little bit. I might have to drag the screen up. And there we go. There it is right there. So at 4.5 seconds, the object is 56 feet off the ground. So you'll type in 56 feet for that next to last question. Now, the time it takes to actually reach the ground, that means the height is 0. So y equals 0. That means the height is 0. And if you look, that'll be right here. It's going to take 5 seconds to reach the ground. Now, there's another answer over here, negative 2.5. We're not interested in negative time. We want the positive answer. So the positive answer, it takes 5 seconds to reach the ground. So from the time it was launched from the top of the building till it reaches the ground is a total of 5 seconds. All right, so that's what you should look like. That's what it should be. All your answers filled in.